Welcome to Lesson 7, example number 4, and they say that again, using the connection in example number 2, what is the allowable P if 1-inch bolts conforming to ASTM A325 in a slip critical connection are used? So here's the big issue. We now have slip critical. And I really haven't gone into what this is. Before, when the bearing type, that means that it's gonna move a little bit, and this plate, that plate hole, it's a little bit bigger, so you can put the bolt through. It's gonna move, and it's gonna hit the plate is gonna hit the bolt, and that's what bearing is. It's bearing, the bolt is bearing on the plate is bearing on the bolt, whatever you want to look at. And the slip critical is they actually tighten this bolt to a point where they tighten it to a point where it's kind of squeezing all of these plates together. So now you not only have, well, actually what you're counting on is that these plates are, the friction between these plates is going to hold in place, so it's not going to move. Before, these plates would move ever so slightly and it would bear, but and that's assuming that it's only going one way, and that's fine, because once it bears, once all the weight of your structure goes, it's going to bear on that one side. It's going to stay there. Slip critical connections are often used when, for instance, let's say a truss bridge or something like that, where you have moving loads, like a truckload or whatnot, and these truckloads are going to, and some members are going to, P might go this way, and then next thing you know, P might switch directions, and so you're going to go back, forth, back, forth. If it was a bearing connection, it would bear on this side of the plate, then it would bear on that side of the plate, and then this side, and before it would be just knocking that bolt back and forth, and I guess that would be more of a fatigue condition, and you want to watch out for that. And when you have those more fatigue-like conditions, you use slip critical connections, and that's what this is. And those slip critical connections are actually, once again, using that friction. And once you can throw your hands together as hard as you can and try to move them. And you can see that obviously that's friction. And they have equations for it. I don't think you're going to be going over that in this study guide or on your tests, because it just gets a little bit more intensive. So let's go ahead and figure this out. One other point before we move on, actually, is we want to ensure, while this bolt, actually, if the slip critical connection is working and it's not slipping, that friction should be holding your connection in place. But if it does slip on accident for some reason, you need to ensure that that bolt is still strong enough to bear. All right, I hope that makes sense. All right, let's move right ahead. And once again, while we said that it's not really going to be bore upon, we still want to go to the bolts on table 1-D in shear. So you go to bolts, and then you go over to, we said it was A325 bolts. Connection type is now SC, which if you go down you can see is slip critical connection. And then you say, oh, well, what's our hole type? And if you're confused, you can go down and look at the bottom. Let's start from the bottom. LSL, we don't have a long slotted hole. SSL, a short slotted hole, we don't have a short slotted hole. OVS, we do not have an oversized round hole, so let's use our standard hole, STD, standard round holes. Then we go to the right, and it says loading. It says S or D, and that means single or double shear. If you want to check that out, go down to the bottom table there, or the bottom index, I guess I would call it, and you see D because we have a double shear connection. And then you go over and you to 1-inch diameter, and you see 26.7, and that's in kips. And we have 2 of these, so I'm going to multiply that by 2, so I get 53.4, I believe, yes, 53.4 kips. And that is our let's call it SC, slip critical load. That's how much we can handle. That's our max capacity for slip. Let's put capacity underneath. Slip critical capacity. And once again, if it does slip, that's our slip critical capacity. Let's go ahead and, well, actually, we already know that it's not gonna. If it does slip, you want to go ahead and check your bearing stuff, which we know from the past in example number 2, since this is using what we use in number 2. The what was it? Let me look. Looks like the bolts is the bolts capacity. Shoot. 2 bolts capacity equals 94.2, and the bearing on the plates equals 104.4. And as you can see, this will pretty much always control. And it might always control. I never like making broad statements like that are 100% definite. So 53.4 is about half as much as your bolt capacity and your bearing, your bolt shear capacity and your bearing plate capacity. Bearing capacity, sorry. Alright, I hope that makes sense. So once again, here's your answer. Because they were asking, using connection example 2, what is allowable P if 1-inch bolts conforming to slip critical connections are used? And that is your allowable P. As you can see, it went down significantly. And once again, if you have any specific questions, go ahead and make a comment, and hopefully I see that comment and I can go back and try to address it. Alright, thank you.